Hello viewers, in today's session we are going to discuss another important form of indefinite integration in which the integrand is of the form that is quadratic over quadratic, right? So in this lecture we are going to integrate this function in which the integrand is it consists of a quotient in which the numerator is a quadratic function and the denominator is also a quadratic function. So here q1 is of the form that is ax square plus bx plus c, and q2 is of the form say px square plus qx plus r, right? So here the integrand is having a quadratic polynomial in the numerator and another quadratic polynomial in the denominator, right? So here we'll see the technique how to integrate the functions like q1 over q2. So what we will do, we'll express q1 as a times q2 plus b times the derivative of q2, and then we have another constant here, say e, right? So we'll express this quadratic function q1 which is present in the numerator as a times q2 plus b times the derivative of q2 plus e, where a, b and e are the constants. So q1 is ax square plus bx plus c, and we have a times q2 is px square plus qx plus r. Then we have b times the derivative of px square plus qx plus r, and then we have another constant e, right? Okay, so here our q1 is x square plus x plus 1, and q2 is x square minus x plus 1, right? So let us use this expression. So q1 is x square plus x plus 1, and then we have the constant a times the polynomial, the quadratic polynomial q2 is x square minus x plus 1. Then we have the constant b, the derivative of q2 is x square minus x plus 1, and then we have the constant e, right? Okay, so now we can write here ax square minus ax plus a, and then we have b times the derivative of x square minus x plus 1, which is 2x minus 1, right? And here we have e. So let us uh, recollect the terms, that is the like terms. So here we have only ax square, and here we have x, here also we have x, so we can write minus a plus 2b, and here we have x, and here we have the constant term a, and here we have minus b, and then we have here e, right? So in the right hand side we have another quadratic polynomial where we have the coefficient of x square as a, the coefficient of x as minus a plus 2b, and the constant term is a minus b plus e, right? Okay, so now let us compare both the sides, the coefficients of x square, x, and the constant term, right? So here the coefficient of x square is 1, so we have a is equal to 1, and here the coefficient of x is 1, so we have the equation minus a plus 2b is equal to 1, and the constant term is a minus b plus e, which is equal to 1, right? So now we have three equations and three variables. So here a is 1, uh, taking a is equal to 1 in this equation, we have minus 1 plus 2b is equal to 1. So 2b is 1 plus 1, 2b is 2. So b is 2 over 2, that is 1, right? So the value of b is 1. And now taking the values of a and b, in the third equation we have 1, minus 1 plus e is equal to 1. So this is 0. So we have e is equal to 1, right? So we have obtained the values of a, b and e as 1. Here we have 1 and here we have 1. So now taking these values of a, b and e in this equation, where we have a times x square minus x plus 1 plus b, and the derivative of this term is 2x minus 1 plus e, right? So we have 1, then we have x square minus x plus 1. Here also we have 1, that is 2x minus 1, and here we have 1, right? Okay, so now we can write it as simply x square minus x plus 1, and then the second term is simply 2x minus 1, and the third one is 1. So now let us take this integral as I, right? So I can be written as this polynomial, that is x square plus x plus 1, may be replaced by this expression, right? So we have x square minus x plus 1, then we have here 2x minus 1, and then we have 1 divided by x square minus x plus 1, and here we have dx. So now we have expressed this numerator like this. So we can now express this integral as a sum of three integrals by splitting this integral at this point and at this point, right? So we have integral x square minus x plus 1 over x square minus x plus 1 dx, and here we have 2x minus 1 over x square minus x plus 1 dx, and here we have integral dx over x square minus x plus 1, and obviously the constant of integration. So now here we have three integrals, I1, I2 and I3, right? So the value of I1 is given by simply dx, because see here this term and this term get cancelled because both the terms are identical, and the integral we have 1 dx, that is simply equal to x, right? Now let us consider I2. So I2 is integral 2x minus 1 over x square minus x plus 1 dx. So we can solve it by method of substitution, because the derivative of the denominator, it occurs in the numerator. So we have t is equal to x square minus x plus 1. So dt is 2x minus 1 dx, right? So we have here 2x minus 1 dx is equal to dt, and here we have t, this is a log of t, right? So here we are using the notation log for the natural log, that is ln, right? So we have log of that is x square, taking t is equal to x square minus x plus 1, right? So we have I1 and I2. So now consider the third integral, that is I3. So I3 is dx over x square minus x plus 1, and this integral is of this form, that is dx over ax square plus bx plus c. And to solve these type of integrals, what we do, we convert this quadratic expression into a perfect square. So we can write x square minus x plus 1 as x minus half square, and then here we'll write minus 1 over 4, and then we have this term that is plus 1. So we have expressed this term like this because when we expand x minus half square, we'll get this term, because here we have, say, a square, then we have b square, then we have 2ab. 2ab is 2 times x times half, and here we have minus 1 by 4, then we have 1. So 2 and 2 get cancelled, 1 by 4, 1 by 4 get cancelled. So we are left with x square minus x plus 1, right? So x square minus x plus 1 can be written as x minus half square, and here we have minus 1 by 4 plus 1, that is equal to 3 by 4, right? So this can also be written as x minus half square, and here we have root 3 over 2 square, right? So now we have integral dx over x minus half square, and then we have square root of 3 over 2 square. So now to solve this integral, we can again make use of the method of substitution. So let us take t is equal to x minus half, right? So dt over dx is equal to 1 because the derivative of x with respect to x is 1. So we have dt is equal to dx, right? So now this integral becomes dt. For dx we have dt, and x minus half square can be written as t square, and here we have a square root of 3 over 2 square. So now this is a standard integral because we know that the integral dx over, say, x square plus a square is equal to 1 over a tan inverse x over a, right? So here the variable is t. So we have 1 over a is square root of 3 over 2. So here we have square root of 3 over 2 tan inverse x. For x we can write t, and here we have root 3 over 2. So this is 2 over square root of 3 taking the reciprocal, and then we have here 2 over square root of 3, and for t we can write x minus half. So the value of this integral I3 is given by 2 over square root of 3. Then we have tan inverse, and if we multiply these two numbers by 2, so we have 2x, and then here we have simply 1, and in the denominator we have square root of 3, right? So this is how we can solve these three integrals, and now our final integral I can be written as the sum of three integrals, right? I1, I2 and I3. So I1 is, and obviously the constant of integration c. So I1 is simply x, I2 is log of x square minus x plus 1, and I3 is 2 over square root of 3 tan inverse and 2x minus 1 over square root of 3 plus c, right? So this is the required expression for this indefinite integral.